So I'm going to do a few of the problems that people had trouble with on page 589. So the first one was problem number 23, which was the square root of 48 to the fourth power. So what I'm going to do here is I'm going to break it up so it's 4 times 10, and then I'm going to leave it as a to the fourth because it's a fourth. It is a perfect square. So square root of 4 is a perfect square, a to the fourth is a perfect square. Square root of 4 is 2. Square root of a to the fourth is a squared. Now, since it comes out and it has an even index of 2, we don't use absolute value. Then what's left in here? Root 10. So that's our answer for number 23. 24 was another one people had a little bit of trouble with. So it's the square root of 50, then m to the third, n to the fifth. So again, I'm going to break that up to perfect squares. So I'm going to do 25 times 2, and then m to the third, I'm going to make that m squared times m to the first, because 2 plus 1 is 3, and m squared is a perfect square. And then n to the fifth, I'll make n to the fourth times n to the first. Again, n to the fourth is a perfect square, and then n is not, but 4 plus 1 is 5. So I'm just going to put a little squiggle under my perfect squares. So now the square root of 25 is 5. The square root of m squared is m, and it's m to the first power. You don't need the 1 there, but I just want you to realize this is a odd exponent, and this is a square root. So because it's an odd exponent, when it comes out of a square root, we have to put that in absolute value. And then I have n to the fourth, which the square root of that is n squared. So let's write what's left. The square root of 2mn. So that is our answer for number 24. 25 is similar again. We have the square root of 147, x to the 6th, y to the 7th. So 147, again, that one's a little tricky. It's 49, square root of 49, times 3. X to the 6th is a perfect square, and y to the 7th, I'll make y to the 6th times y to the 1st. All right, so our perfect square is 49, x to the 6th, and then y to the 6th. So the square root of 49 is 7. Square root of x to the 6th is x to the 3rd. Again, it's an even root, and it comes out odd, so we do need absolute value. Y to the 6th is going to be y to the 3rd. Again, that's odd, so I'm going to put them both in absolute value. You don't have to have them separate. And then what's left is a 3 and a y. So 7, absolute value of x to the 3rd, y to the 3rd, square root of 3y. All right, the next one was 32. All right, so the square root of 9x to the 5th y over the square root of 12x squared y to the 6th. So in problems like this, or what I really like to do, because they're both square roots, is I like to think of it as one big radical, and I'm going to write it as a fraction that's inside of that radical. So then what I'm going to do is I'm going to actually simplify my fraction. So 9 over 12 is the same as 3 over 4. X to the 5th divided by x squared, subtract those exponents, and then y divided by y to the 6th is y to the 5th. So now what I'll do is I'll break that up so I have perfect squares. So I have 3, and then x squared times x. You know what, I'm going to make them separate radicals now. That way we have that numerator radical and the denominator. And then I have the square root of 4, and then y to the 5th will become a y to the 4th times y to the 1st. So x squared is a perfect square, 4 is a perfect square, y to the 4th is a perfect square. So what I get is x, and again that will be absolute value, root 3x over 2 y squared, again I don't need absolute value there because it's even, and then root y. Now I can't ever have a radical in the denominator of a fraction. That's not going to be called simplified. So what I need to do is I need to remove that radical, and the way I remove the radical is I'm going to multiply by root y. And the reason why I multiply by root y times root y is really square root of y squared. And we talked about this in class. If you have a square root and a square, they undo each other. They're inverse operations, so we just get y. So now I've successfully removed my radical from our denominator. So my denominator will be 2, and then I have y squared, and this again becomes a y. So what do I get when I put that together? I get 2y to the third. Since it's an odd exponent, you need the absolute value now. In the numerator, let's look back up here, we have the absolute value of x, just fine, and then we're multiplying root 3x by root y, so it's going to be now absolute value of x, root 3xy. Now we'll just check, can we simplify anything that's outside of the radicals? No, we cannot, so that is our final answer for number 32. Absolute value of x, root 3xy over 2, and then the absolute value of y to the third.